So now let's take what we've learned about finding probabilities and the central limit theorem and let's apply it to a real life problem. So we have the combined score, this is both verbal and quantitative reasoning, on the GRE is normally distributed with a mean of 1066 and a standard deviation of 191. Now that should sound familiar because we've already seen this idea back in chapter 7. The GRE, remember, is like a big exam that graduate students need to take in order to, well, before you become a graduate student, you take this exam. Suppose you're going to take n equals 15 randomly selected students to take the GRE on the same day. What is the probability that a randomly selected student scores between 900 and 1200 on the GRE? Whoa. Okay, so a randomly selected student, see that right there? Oops, sorry. That's talking about one student, one. So if that's the case, then this isn't really a chapter 8 question. A randomly selected student is a chapter 7 question. So let me make the note of this. Note, a student equals a chapter 7 review question. All right, so let's remember how to find that. We're going to need to know the shape. Oh, but we do know the shape. We know that it's normally distributed, has a mean of 1066, standard deviation of 191, and we want to find the probability that it's between 900 and 1200. So we're going to need normal CDF. So let me type up some stuff and draw a picture, and I'll be right back. There we have a lovely normal curve. You can see I've put 1066 in the middle. I have 900 over here on the left, 1200 over here on the right, and I've shaded in between. And if you're wondering, hey, should I be drawing a curve like that? Absolutely, you should. You draw a picture, you shade it appropriately. You should know that 900's on the left, 1200's on the right, and so on. And I even added those instructions in here just to make it extremely clear to you. Okay, so we can see that the computer thinks it's 0.5661, but of course you don't have Minitab on you to be able to do it that way, so you're going to have to use normal CDF, so number 2, 900, 1200, 1066, and the standard deviation is 191, and we're working with the standard deviation here because n equals 1, and we see 0.5661. And you can see that's why I'm talking about x here, not x bar, but x. And that's because n equals 1 in this case. And since n equals 1, that makes this a problem that has a standard deviation rather than a standard error. All right, now let's describe the sampling distribution of the sample mean for samples of size n equals 15. So that's when we need to use shape and center and spread. So the shape is going to be normal, and that's because it was normal to begin with. But if your population distribution is normal, like this one is, see right here, this is for n equals 1. If it's normally distributed for n equals 1, then it's normally distributed no matter what your n is, right? So it's okay that n is only 15. It's all right that that's smaller than 30 since the original population distribution was normal. And then the center will be 1066, and the spread, however, will be the standard error, which is sigma divided by the square root of n. Let me type all that up, 1 second. All right, there we have it. It's normal because it is given that the population distribution is normal. Therefore, it doesn't matter that our sample size, which is 15, is below 30. Okay. All right, then center is 1066. The standard error is sigma divided by the square root of n. That's 191 over the square root of 15. So let me grab that. 191 divided by the square root of 15. And I get about 49.316. Okay, so let me highlight that. And then similarly here, let me highlight this as our center. Oop. I pressed the wrong button there. There we go. All right, now what is the probability that a random sample of 15 students has a mean, see that? A mean GRE score between 900 and 1200. Well, we're not talking about single individuals anymore. We are now talking about a group of 15 having an average. So that is going to fundamentally change this probability. So let me type this up. I'll be right back. All right, there we have it. Now you can see I have so much of this curve shaded. So the computer thinks that the area is 0.9963. It thinks so much is in there. And that's because it is, but I'll show you that in a second. So there's a lot in there, and that means that I want normal CDF, but I'm talking about X bar this time. So I want 900 to 1200, 1066, but then 191 over the square root of 15. So let me find that. So I'm going to take the distribution menu, number 2, 900, 1200, 1066, but here I want to do 191 divided by the square root of 15. You don't have to bother with closing your parentheses. It'll be all right when you paste it in. Although if you want to be more careful, you can see 0.9963. It's a lot in there. Okay, so it's 0.9963. We said it was easier to be around the center, and we weren't lying. And I want to illustrate the difference of these two graphs that we just looked at. So I'm going to bring up another program so you can see the difference here. So these are those two graphs side by side, and you can see the 0.9963 is this tall center curve, and there's just that little bit down here in the tail that's not shaded. So that's why it's 0.9963, whereas the other one we did had 0.5661 in that center region, right? So you can see the two curves are fundamentally different. The shorter gray curve has a standard deviation of 191. The taller, skinnier curve has a standard error of 49.316. And that means that way more of the data is between 900 and 1200. If you'd like, you could draw a little sketch of that over on the side of your paper so you can explain the difference between the two curves. All right, now let's find the first quartile. Now remember about your first quartile. Your first quartile means that 25% is below you. So for example, on an exam, if you score in the first quartile, you're in the bottom quarter, which is not necessarily a good place to be. All right, so let me draw a picture of that. Okay, so you can see here, we know that this area is 0.25 because if you're in the first quartile, you're on that bottom part. What we're looking for is what is X bar right here. So the X bar is that first quartile. And to find X bar, you don't use normal CDF, that's inverse norm. Remember, you take the left tail area, which in this case is 0.25, then you take the mean of 1066, and then we're talking about an X bar, not an X value. So instead of doing 191, you actually want 191 over the square root of 15. And let's find what that value is. So let me grab the calculator. So I'm going to go to inverse norm, which is number 3, 0.25, 1066, 191 divided by the square root of 15. I'm going to paste that in, and I get 1032.7. 74 or so. And there we go. That would be your score. So it's the score it's really the sample mean, right? The sample mean score, which is the inverse norm. And there we have it. And I shouldn't have said 4 decimal places here. I should say 2. We only need 2 decimal places because this is an actual value. All right, I'm worried about my ability to do the last problem in the amount of time that we need. So I'm actually going to stop right here and do the last problem in the last video. So I'll see you back here then.